Hello everyone, my name is Dee Dee Butler and I'd like to welcome you to today's webinar, Geostatistics and Vulcan. Your host today is Matt Bourget. Matt is a geological engineer who works with the Vulcan Services team in North American region. A few things before we get started. First, today's webinar will conclude with a question and answer session, so feel free to write in questions in the panel on the right-hand side of your screen. Also, you will receive a link to a recording of this webinar by email in case you'd like to see it again. It will also be available on the MapTech website at a later date. I'll now hand it over to Matt.
Thanks, Dee Dee, and thanks to everyone for attending. As she mentioned, today we'll be going through the geostatistics tools in Vulcan. And one of the main points that I hope to convey today is how Vulcan is an all-encompassing toolbox for a resource geologist needs from the start of his project to the end. And geostatistics oftentimes gets a bad rap as being a complicated can of worms or kind of black boxy. So for the sake of this presentation, we're going to break it down, geostatistics that is, into 6 simple steps. The exploration, so starting with your raw data and your drill holes and any outside data, your domain modeling, statistics and data analysis, numerical modeling or estimation, simulation, checking your model, and then finally reserves. So again, depending on what type of deposit you're dealing with, what data you have available to you, and the purpose of your model, those are kind of dictate which tools you use. But at any rate, we're going to go through each one of these as if we were generating a global resource model. And then just a note as far as how I'm going to structure this presentation is I'll go through some PowerPoint, have some general discussion about Vulcan, and then I'll actually switch over to Vulcan and do some live demonstrations. So just kind of bear with me a little bit. We'll be toggling back and forth between the presentation itself and Vulcan. So starting with the first step in our process of exploration, Vulcan has a fully 3D interface where you can view all of the data that you already have. So drill holes, triangulations, aerial photos, geotech data, geologic interpretations. And you can zoom in and rotate these all from a very large scale all the way down to a very small, a single interval within a single drill hole. So zooming in and rotating, and what's important about this is you can get all of these different data types in one place in one screen, and then use the 3D window to kind of help get a spatial understanding and a connection between those data types. Aside from the 3D window, I've also got a robust database option. So we can either have Vulcan's own database, which we'll call an ISIS database, where everything is hosted in-house in Vulcan, or we also have the ability to set up a connection to Acquire or any other ODBC connection, just SQL access, things like that. And then within those database tools, we have really powerful database validation tools where you can run through the kind of standard checks for your database, your things like overlapping intervals, duplicate hole IDs, things like that. I think it's really important before you jump into kind of the more glamorous parts of geostatistics and resource modeling to spend a lot of time really validating your database, and Vulcan's got really good tools for doing that. So I'm going to toggle over to Vulcan and just load up some stuff in the 3D window and then just see how the interface is with different data types loaded. So first I'll load some drill holes. And then just a comment about this data set. It's a Mississippi Valley type lead zinc deposit, so real flat, low-lying, close to the surface. So if I put this topography, and I'll make it translucent, we've got our topo, our drill holes, and then I can load a set of geologic interpretations, which we will talk about a little bit more later on. Not only is it you have the freehand rotate and zoom, but Vulcan also has really powerful sectioning tools where you can get into section view, easily navigate forward and backwards through your data while the whole time really keeping track of where you're at in 3D. So I'll kind of demonstrate that later on, but I do want to point out that the section tools in Vulcan are really robust and you can easily use them with a nice interface. So I'll toggle back to the presentation, talk about the next step in our process, which is domain modeling. So Vulcan's got tools for creating 100% explicit model. So that would be your classic hand-drawn, digitized in section view geologic model. We've got, like I mentioned, the section tools, a full suite of CAD tools for actually digitizing and editing those polygons, and then the triangulation modeling tools when you want to go ahead and actually create your solid. And then on the other side of that, we've got an implicit modeler, which will let you generate these solids and these domains 100% from your data. You can just enter in a handful of parameters into the implicit modeler, let it run, and then what you'll end up with is a nice block model with the domains flagged as well as the solids representing your domains. One thing that's really nice, I think, about the implicit modeler is that it allows you to generate pessimistic and optimistic results from your same data set. All of those results are going to honor your drill holes. So with those optimistic and pessimistic results, you can kind of get a good idea of how much spatial, I guess, variability you'll have in your domains with your data when you're, for example, if your most pessimistic result is not that different from your most optimistic result, you can kind of be a bit more confident in where those boundaries actually are. Outside of the explicit option and the implicit option, we've got kind of what I would call a hybrid option, where the user can digitize a handful of polygons just like you would if you're making an explicit model, but then you can feed those polygons into the implicit modeler and it will generate boundaries honoring your polygons, and then outside of those areas where you've drawn those polygons, it'll actually use the other implicit modeling tools to calculate the boundaries. So the hybrid is kind of a nice happy medium for those who aren't really ready to jump fully into the implicit world where everything's data driven but don't necessarily want to spend the time to go the explicit route. So if I switch back to Vulcan, I just want to show a couple of those results of what we get from the explicit model generation and then from the implicit, and make a few comments about those. So here, these polygons are the actual geologic interpretations from the explicit model you saw in the presentation or in the PowerPoint. And here you can see that it's exactly what it is. Every one of these matches the polygons of that section. And then I can also load the implicit model results, and we can compare. So a couple comments about the implicit model results here compared to the other one is a lot of people will kind of judge the results of an implicit modeling run by how well it actually recreates what was done by hand. So if you just notice this result compared to what we have with the hand result, very similar geometry, very similar shape, and very similar volumes. So here is a great example of the implicit modeler generating a really nice looking ore body compared to with what one might draw by hand. So toggle back to the presentation, and the next step in our 6 simple steps of geostats is statistics and data analysis. So Vulcan's got a full range of your standard charts that are commonly used in industry for geostats, such as your histograms, your probability plots, scatter plots, those types of things. What's nice about those is you can plot them all up in Vulcan, or you can also export them out to Excel, where you kind of get the added formatting ability. Beyond those charts, we've got the contact profile analyzer or the boundary plots, which helps give you some qualitative information based upon how either hard or soft your contact is between your domain and samples outside of your domain. For those of you who may be using multivariate data sets, we've got the principal component analysis and minimum maximum autocorrelation factors, or PCA and MAF. So again, depending on the data set, the type of model you're doing, you may want to use those. The database drift analyzer, again, for plotting your grade as it travels through space, so helpful to identify trends in your data set in all three directions. We've also got a handful of declustering options available in Vulcan. And then lastly on this panel, the Vulcan Data Analyzer. And that's going to be what I'm going to show a quick demonstration of. But what it is, it's a really handy, quick to pick up, good user interface way of generating variograms and variogram models. So the screenshot on the right there is actually from the Vulcan Data Analyzer. And I'll toggle over to that. And as I mentioned, the data analyzer currently is where we're going to generate our variograms and variogram models. So the first part of using the data analyzer would be creating a fan variogram to help identify your major direction of continuity and seeing how well that lines up with what the conceptual knowledge you already have about your deposit. So how this works, for the fan variogram, you just configure a couple really standard variogram parameters, your lag size, your angle tolerances, and then it computes a variogram in all those directions. And if I toggle, or if I move this little bar around, we can see that the variogram changes at each little orientation that it gives. So this is just a good way of helping, again, find that primary direction of continuity, see if it lines up with what you expect, or if it's just kind of showing a artifact in your data. After you've identified this major direction with the fan variogram, you'll go ahead, create your three directional variograms, and then the variogram model. And what's nice about this also is, aside from how interactive it is, once you have your variogram model, you can just export that and then import it into any option in Vulcan which requires a variogram. So estimation, support analysis, whatever it is. So back to the presentation and the next step, which is numerical modeling or estimation or simulation. So Vulcan has linear and nonlinear methods and techniques of grade estimation or simulation, starting with your simple or your standard inverse distance. You have both types of kriging, simple kriging, ordinary kriging. And then if we move into the nonlinear methods, indicator kriging, co-kriging, both types of simulation, Gaussian and indicator. And then we also have localized uniform conditioning. So again, all this is going to depend on your deposit type, what the purpose of your model is. But again, you have the whole suite of options here that you can use. And then specifically, when we talk about Vulcan block models, a couple things I want to highlight there is they can be rotated and subblocked, and you can have them rotated in all three directions, and then we can view literally billions of blocks on the screen in seconds, which is really powerful when you're wanting to view large block models and start with your visual validation. So I'll toggle over to Vulcan, and I'll just I'll load up on the screen some block models. So here's our domain that we've created from the first few steps. And what's really nice about Vulcan's block model viewing tools is that depending on how you want to view your data, whether large scale or on a block by block basis, we have an option where you can do that. So here I'm just going to load up the large blocks, load up blocks. We can view them on a large scale. So here, once it loads, we're viewing our data at a large scale, deposit scale, and we can see things like, obviously we used some sort of linear interpolator here. We've kind of smoothed our data, but we can kind of see the trends and how our grade is distributed throughout the deposit. if I get into a section view, now is when we can start viewing the blocks on a more specific level. We can actually inquire on a specific block, get the details of that block reported, all the values of all the variables in that block, and then we can even take it one step further and see which samples were used to estimate that block, which samples were found within the search ellipse for that block but not used. So you can get really specific. So getting into section view and moving forward and backwards is really nice when we consider the next part of our geostatistics process of model checking. So we've got visual validation where we'll load up our blocks in section view, compare them to our composites or our samples, just to make sure that our high-grade blocks are surrounded by our high-grade samples. We've got cross-validation, jackknife. So that would be the plot below where we're looking at a cross-validation scatter plot showing our true grades plotted against our estimated grades. That'll give us an idea of what sort of bias we may have introduced with our estimation plan. Then the chart on the right shows a swath plot. So we're looking at the grades of our block model compared to our database as we move through space. And there again, that's going to help us kind of qualitatively do some dummy checks, I guess, of our model, make sure we haven't over-smoothed to a level that we're not comfortable with. All these options together help us visually and numerically validate our block models. So I'll toggle back to Vulcan. Here we're already in that blocks section, so what I'll do is I will remove our drill holes and then actually load up the composites or the samples that we use for this database, or for this block estimation, I should say. Okay, so here's all our samples, and on this particular section plane, it does look like we can visually validate. I might want to see what's going on over here, which samples were used, why I have a couple high-grade samples in these lower-grade blocks. But what's nice about this is I can rotate around or move back and forth through my sections, just freehand or at a fixed distance, and I can open up another window here, and it will help me know exactly where I'm at in 3D as I move along. So you can see as I rotate or as I move my section plane, the window that I've brought up is actually showing me where I'm at in 3D. So that's really helpful just to know exactly where you're at. So going back to our presentation, the last step in our geostats process would be reserves. Vulcan's got multiple different options of generating reserves, both a chart, a grade time curve like we see here, or just reports. So depending on what you're after, you just configure your parameters, whether it's economic or cutoff grades, and then you'll output those to either the chart or the report. So as we kind of get into the end of this, Vulcan contains extensive geostatistics tool sets. And again, depending on what your deposit is, what the purpose of your model is, you can use these tools in combination to get a better understanding of your deposit. Or if you're at an operation a little further along in time, production environment, you can use it to help your grade control decisions, your drill hole planning, and then your capital investment. And again, these techniques are easy to use, repeatable, and auditable. So if your model's up for audit, we have a nice paper trail of report files that are automatically generated to see what your specifications were for any given time. And then another point I want to make is that the work never ends with just a validated resource model. It's always going to be something downstream. And what's nice is we've got fully integrated engineering tools all in the same package. So we can take our multiple realizations from a simulation run, feed those into a stope optimizer or a pit optimizer, and then continue this process downstream, all within the same software. So I think with that, Dee Dee, we can turn it over and answer a couple questions.
Thank you, Matt. As I mentioned before, please write in any questions through the panel on the right-hand side of your screen. Let's see if we have any questions so far. All right. Can you validate using Herco analysis?
Yeah, good question. So in Vulcan, we would use our support analysis tool for that. So I'll kind of bring up that panel and show what that looks like. But the support analysis has the three algorithms to use: discrete Gaussian, affine or affine, and indirect log normal. So depending upon where you're at in your process, you can use support analysis as either a data analyzer tool or as a validation tool. On the data analyzer part, you can take your samples database, plug in a range of block sizes, and then you'll be able to generate theoretic distributions using one of these support correction algorithms. On the back side of it, it'll be nice where you can take your existing block model that you've estimated, run it through support analysis, and see how it compares to what a theoretical distribution would look like at the same block size or at the same scale. So yep, we can do support analysis using the support analysis tool.
Great, thanks. Can you show how you recalculate for a different lag size in Data Analyzer?
Yep. So I'll bring up the Data Analyzer. And then if we look over here on the right-hand side where we have all of our variogram parameters, you'll notice that lag size is one of those parameters. So you can just come in here, maybe you want to change your lag size, and then it automatically updates your chart. And what's really nice about this is, say I want to make my lag tolerance half of my lag size, which is not uncommon. If I were to change my lag size, it automatically updates my lag tolerance to maintain that relationship of what I input on my own. And then aside from just being able to come in here and type specific lag sizes, you can use this bar here. It's just a simple slider bar to test a whole range of lag sizes and see where you're starting to get some good variograms coming up.
Great, thanks, Matt. Looks like we're nearing the end of our time today. On behalf of the entire MapTech team, thank you for attending. If we didn't get to your question today, we have your question and contact information, and we will reach out to you offline. If you have additional questions, feel free to contact Matt directly or email support@maptech.com. We hold a different webinar each month, so please visit maptech.com to view the entire schedule. Thank you and have a great day.